This is a multiple choice question from the August 2016 Algebra 1 Regent. The function f of x is equal to 3x squared plus 12x plus 11 can be written in vertex form as, and we have four choices. What we need to do is switch that f of x equation from standard form, y is equal to ax squared plus bx plus c, into vertex form, y is equal to x minus h squared plus k. To do that, we're going to use completing the square. F of x is equal to 3x squared plus 12x plus 11. Problem is a bit more tricky than the ones we usually have, because whenever you're using completing the square, you want your a value to be equal to 1, and in this case the a value is 3. So let's look at how we're going to do that. The first thing we're going to do is move the constant to the other side. F of x minus 11 is equal to 3x squared plus 12x. Now we need our a value, our a is always the coefficient of the x squared, we need that value to be equal to 1. If we divide everything on this side of the equation by 3, then we'll have our a value equal to 1. Then we'll also have to divide everything on the other side of the equation by 3. Instead of doing that, we're going to factor out the 3. We're going to take 3 out of the first term, so we're left with x squared. We're going to take 3 out of the second term, so we're left with 4x. And the other half of our equation, we didn't move the 3 anywhere, we just factored it out, so we don't have to divide the other side of the equation by 3. It's still f of x minus 11. Whenever we're doing completing the square to rewrite our equation from standard form into vertex form, we always want to have the side of the equation with the x's to be a perfect square trinomial, which means it's two of the same factors like x minus 4 and x minus 4. That trinomial, when those are FOILed out, would be a perfect square trinomial. We need to rewrite the right-hand side of this equation as a perfect square trinomial. To do that, we always want to take 1/2 of b and square it. b, in this case, it looks like it's 4. So 1/2 of 4 is 2, and then 2 squared is just 4. But it's not really 4, it's really 12, because we still have a 3 outside. So we're going to have to add 3 times 4 to that side. And since we're adding 3 times 4 to that side, we also have to add it to the other side. So plus 3 times 4. On the left-hand side of the equation, we could just add, we could do f of x minus 11 plus 3 times 4 is 12. So negative 11 plus 12 is plus 1. This is equal to 3 times x squared plus 4x. Either we could add 12 outside over here, or we could bring the 4 inside and have the 3 combined with that 3 over there. That's what we're going to do. So we're going to add 4 inside. We could have added 12 outside, but instead we're going to add 4 inside. Now what's inside the parentheses is a perfect square trinomial. So we can rewrite this as, we could find factors of 4 that add up to 4. They're the same thing. Factors of 4 are 2 and 2, or negative 2 and negative 2. The ones that add up to 4 are positive 2 and positive 2. So we're going to rewrite what's in the parentheses as x plus 2 times x plus 2. Now don't forget about the 3. This doesn't need to be in other parentheses because multiplication order doesn't matter. So we have f of x plus 1 is equal to 3 times x plus 2 times x plus 2. Since we have two of the same factors, we can combine them and do x plus 2 squared. So then the other side of our equation is still f of x plus 1 is equal to 3 times x plus 2 squared. Then we're going to subtract 1 from both sides so that we have our f of x on the other side of the equation. F of x is equal to 3 times x plus 2 squared minus 1. And if you look back on the answer choices, this is choice number 3.